When you run a simulation, it's important to remember that the longer you run it for, the more accurate the results you're going to get. For example, if you run the coffee shop simulation with just 100 customers, you're going to get very, very inaccurate answers. And one way to observe this is to go to the spreadsheet and just create a cell where you average the first 100 wait times and test it many times. You can test it by pressing F9 to refresh all the random numbers on your computer. You're going to see that every time you run the simulation again, you're getting quite a different answer. Now, we did our simulation with 1,000 customers. You will see that that number changes much less every time you rerun the simulation, but it's still changing a fair amount. If you want a really accurate simulation, what you're going to have to do is create hundreds of thousands or even millions of customers. If you do that and you average 1 million wait times, you're going to get a very, very accurate time that barely budges between two different simulation runs. Let me give you a problem to think about. When we solved this problem via simulation, we got an answer of an average wait time of 55 seconds. However, you could have tried solving this problem with the MM1 formula. And if you use the MM1 formula, you would have gotten a very different answer. You would have gotten that the answer was 250 seconds was the average wait time of a customer. So if you use the MM1 formula, you would have been way off. You would have guessed that a customer waited typically more than 4 minutes rather than less than 1 minute. The difference is that the MM1 formula assumes exponential inter-arrival times and exponential service times. And our simulation, we assume uniform inter-arrival times and uniform service times. So try to think about what's so different between exponentials and uniforms and what's driving the difference between these two results. I'm going to give you one more problem to think about. So let's say the measurements are not really uniform and they're not exponential either. Let's say that we measure inter-arrival times and service times and they turn out to be normally distributed. Let's assume the inter-arrival times are normally distributed with mean 60 seconds and standard deviation of 15 seconds. And let's assume the service times are normally distributed as well, but with mean 50 seconds and standard deviation of 10 seconds. Can you calculate what is the average wait time in this queue? So to help you out, let me give you a hint that you can use the following formula to simulate normal distributions in Excel. It's a norm inf of rand and the mean and the standard deviations you want. When you get the answer, how does this one compare to the exponential one and the uniform? Do you think you're going to get longer wait times or shorter wait times?